Hello again. Now we're going to calculate the factor tree of 132. Okay? So let's begin. The first thing that we're going to observe is we're going to notice that this has a 2 at the end. That means that its last digit is an even number. So we know it's going to be divisible by 2. Okay? And so let's begin by writing our 132 at the top of our tree. Okay? I know it's going to be able to be broken by 2. I'm going to be able to divide 132 by 2 because its last digit is even. And so now let's do that here on the side. We're going to ask ourselves, how many times does 2 go into 132? Okay. So I ask myself, does 2 go into 1? It does not. Does 2 go into 13? Aha. 2, 4, 6, 8, 10, 12, right? So it goes in 6 times. Okay, so I put the 6 not over the 1, but over the 3 of the 13. Okay? 6 times 2 is 12. So I put that here like this. And I ask myself, what is 3 minus 2? That's 1. What is 1 minus 1? 0. So I don't have to put it. And then I bring down my digit like this. 2. Okay? I then ask the question, okay, how many times does 2 go into 12? We know that that's 6. So what I'm going to do here is I'm going to write, okay, 6 here over that 2. 6 times 2 is 12. 2 minus 2 is 0. 1 minus 1 is 0. And there's nothing to bring down, so the division stops. So I saw in this situation that 132 is equal to 2 times 66. Okay? Like this. So here, this term is already done. Okay? And then I can see here that 66, okay, 66 ends with a digit that is even. So I know I'm going to be able to split it up by 2. I'm going to be able to divide it by 2 evenly. So let's do that here. 2 goes into 66. Okay, I ask myself, how many times does 2 go into 6? 2, 4, 6. It goes in 3 times. So I'm going to put my 3 here. 3 times 2 is 6, like this. I subtract what is 6 minus 6? That's 0. I then bring down my 6 here and ask myself, how many times does 2 go into this 6? Again, 3 times. So I put that here. 3 times 2 is 6. And then I ask myself, what is 6 minus 6? That's 0. And then, of course, the 0, I just bring it down, but it's not going to make a difference. And then there's no digit here to bring down anymore, so it stops. Okay, so I can see that 66 is equal to 2 times 33. Okay. Now I want you to observe here that this number, 33, does not end in an even number, right? So here is where we start to see something more interesting happen, okay? Because we know that we cannot divide it by 2. But it's interesting here that you can see that it looks like it might be divisible by 3. So let's try that here with long division, okay? I want to ask myself, how many times does 3 go into 33? Okay. So I ask myself, how many times does 3 go into 3? Of course, 1 time. 1 times 3 is 3, okay? Then I ask myself, what is 3 minus 3? That's 0. Once I perform my subtraction, I bring down my next digit like this, okay? And I ask myself, how many times does 3 go into 3? Aha. 1 time as well, again. 1 times 3 is 3. Then I subtract these and I get 0. And so I can see, aha, 33 is 3 times 11. 3 is already a prime number. 11 is a prime number. Okay? And so we can see that our factor tree is complete. Okay, this is my factor tree for 132. And let us write down how we can interpret this result for the use of our future examples. Okay, so how do we do this? Well, what we can interpret this as is as 132 equals 2 times 2 times 3 times 11. Okay. Or, and of course here we have a 2 times 2. So if we want to use our notation from last time, we could also write this as 132 equals 2 times 2, or in other words, 2 squared times 3 times 11. Okay. So these both convey the same information, and you can use whichever one you feel more comfortable with, and it will. And this is the information that we're really going for when we're using the factor tree. Okay, because you will see that in our future examples when we use this, when we use the factor tree, that this information will help us do calculations more effectively. Whether it's finding the square root, which we're going to do much later, whether it's adding two fractions with unlike denominators, finding the least common multiple, which we can then use as the best denominator for both of them, or whether we're using this for some other procedure. Okay. I hope you have again enjoyed this example, and I'll see you again soon. Thank you.